I have worked for Gapco before, one of the major oil companies in Egypt, and we did so many in water flooding. Currently, I'm working for Shell as asset development lead. Before that, I had the chance and the opportunity to work on water flooding for 5 years. Although the water flooding, one of my favorite topics, I consider this is one of the most challenging sessions which I have to deliver. Actually, I did the presentation so many times. Every time I do another presentation, because there are so many areas in the water flooding which I'd like to cover. Then I come back and say I do another topic. So it would be much better if I teach this in a few days, more than 1 hour. But I will do my best that I cover this topic in half an hour or so. And cover so many, giving some tips and highlighting some design aspects. But I will share with you my presentation. But if you have any problem, just let me know. Okay. I will share my screen. Yes, here. So I think I don't have the. Okay, yes, this one. Sure. So, can you see my screen?
Yes, we can see.
Okay. So this is almost like introduction to the water flooding. Okay. So I will start firstly with the objective of today's session. I mentioned course, but something like a quick session introduction. What I would like you to know about this session, that I'm going to tell you some of engineering, geological, and operation aspects of water flooding. So I will cover some aspects. I will not go deep, but you are more than welcome to ask any question about any of those topics. That I will go deeper whenever you want me to do. Then I will provide you some understanding about the issues and responsibilities of various disciplines, different disciplines. That usually water flooding is not one discipline aspect; it's different disciplines, but they have to work together. It has some geological operations. You have some wells activities. So you have many disciplines coming together, and it coming in the heart of the water flooding, the chemical injection, and the chemists. Chemistry setting one of the key driver of success of the water flooding. So that's why I will put some light on different discipline contribution to the water flooding project. Then I will reinforce a significant point by lectures. So I will show some examples, real examples. Then I will provide you some link to additional water flood information and tools that help you to manage water flood. Then the first which comes to us, why we are talking about water flooding, why water flooding is such famous. Actually, because most widely used fluid injection process, we can see water flooding everywhere, in every country, in every company. You will find water flooding is very famous in everywhere. This is actually because the water is available everywhere as well. So it's not it's very challenging that you find gas or polymer chemicals. Water is available everywhere. That's why it was one of the key secondary recovery methods all over the world. It has been proven that this method can increase oil recovery. So some other methods it doesn't work other times, but water flooding proved to be one of the EOR methods that can increase oil recovery. It's very mature technology, and I will tell you why it's very mature technology. You can see this technology started in 1880s, and something even very long ago, and it was accidental. And it was water flooding start by accident, and suggestion made after that to start work on water flooding. But until 1921, it was illegal to inject water in Pennsylvania. This is the first field area all over the world that start oil production. So until 1921, it was illegal activities. But after 1921 and 1922, the first line drive pattern was introduced. But if we are talking about amateur technology, we are talking about a technology that has been in the industry for more than 100 years right now. So the water flooding proved to be successful since 100 years. So we can celebrate next year the first line pattern in the world. Then the 5-spot pattern introduced 2 years later. Several injection projects were initiated in 1930s. Water flooding began to be very popular in 1950s. And this is why one of my honor to work for GAPCO. Usually you have seen that water flooding started there in 1960s and 70s. So that's why you start all over the world to see since 1950s this project is widespread all over the world. History has influenced our water flood terminology, either primary or secondary or tertiary. Okay, that's why I'm saying this is really mature technology. Okay, this graph which you have seen right now is showing the value of water flooding. So this is different fields. Those bars showing you what's the recovery factor under primary water flooding and what's the recovery factor under water injection. If I'm starting from far left, you can see a recovery factor of one of the fields is 5%, but with water flooding you can go up to 25%. So this is adding 20% out of the recovery. And it's different from field to field and from asset to asset. Depends how you manage the water flooding, how you integrate with other discipline, how you understand your fields, how you operate the water flooding. Because although it's really mature technology, however, it's because of the integration. Any problems in the integration between a discipline and another discipline can create a lot of problems. But you can see a lot of failures in the water flooding until now. And I can show you at the end of the presentation how it fails because bad integration. But usually I'm calling my course in the water flooding integrated water flooding, because water flooding is not only about reservoir management, although it's really critical part from the water flooding, but integrating with the project, which material you are building on the surface, which pipelines you want, which grade you have on the surface, which flow meter you are using to measure the rates, which chemical strategy do you have, but which completion strategy do you have, but everything integrating together, and what's the impact of such produced water on the production, and how you manage the production with water injection. All those type of things is coming together as one part. And usually when I have the time to present the water flooding in longer period, I start with showing a blood donation, and for me water injection like blood donation. The body itself, when it's lose its energy, it needs blood, and the blood gives its energy. However, the blood, it must be compatible with the body blood. If you the human being a different type of blood, it might not help him. It might cause him fatality and death. If you give him through polluted, or you are using the wrong tools, also you might cause him death or different diseases. But not usually if you give a blood to a human being, he will survive and get back to life with energy. You might kill him with blood. The same with water. If you introduce water which is different, which is not part from the environment or the system, introduce a different material to the system, you might lose your reserve, you might lose your recovery, and get a lot of problems. But you might go to introduce energy, introduce efficiency, and increase the recovery factor. However, you get back with really bad effect. And sometimes it becomes non-economic. You get yourself in non-economic situation. Okay. So if I move forward, I will ask myself a question, and you as well. How I get my water? Water is available everywhere, but how I get my water? You have three types of water that you are using for water injection. First of all is fresh water. You can get it from lakes, from rivers, and the issue that this water is not available all the time. And it's not only oil industry need this water, but it needed by human being, by animals, and by, for agriculture. So it's not really available, although you can find it, but it's not really available. And by the way, fresh water can create so many other problems. I will tell about it later. For example, you have aquifer, you have alluvium beds. This can create SRB, which is bacteria, which coming out with H2S. Then you have the salt water, and you can find the salt water either in ocean or seas or aquifers. And the aquifer, you have different type of aquifer. You have shallow aquifer, you have deep aquifer, and the third water you can get it is the produced water. What does it mean, produced water? Usually you have water produced with the oil, and you might use this oiled water to re-inject it once again in the oil zone. So you need to be very careful about choosing which type of water to be injected, because each type of water has its own advantage and disadvantage. I started, even now, my start is not with, I think everyone expects me to go through a map and showing where I drill the wells and how I drill this wells, and telling about the theories. I will put some light on the theories. However, what's really important and missed in the practical life, how we manage such a project. Choosing the water is the first key factor in developing water flooding. Okay, if you think that I'm moving so fast, please someone let me know and tell me that please slow down, because I think I'm running a little bit fast. But if anyone wants me to slow down, please let me know. Okay, this showing how in the integration. And this is how it looks like the project. You have here, if you see my mouse, you can see here, this is your reservoir, and where you need to drill producer and injectors. It might have one layer, multi-layers, different layers. It might be inclined, it might be horizontal. You might have different reservoir realization. Then you need to find a source of the water. Like I said, since a while, you have to find the water either in lake. You might drill a well to get it from aquifer. You might find working in the Gulf of Suez. We used to use water from the Gulf. While I'm working in the Western Desert, we get the water from, we drill wells. Sometimes it's shallow reservoir that has the water. Sometimes really deep reservoir that has the water. And each type of water has its different characterization that is impact the whole development. Okay, in GAPCO, for example, when we brought the water from Gulf of Suez, it's full with oxygen. It's full with bacteria. It can create a lot of compatibility issues. That's why you need to have big plant for water flood processing. You need to bring the water, clean the water, deoxygenate the water, add some inhibition so that you kill the bacteria before you inject it in the reservoir. So that's why if you go for GAPCO, for example, you have the chance to visit Ras Shukhair, you will find really big plant. This plant full with equipment. It has its own staff that operate it from day to day. Okay, if you go for the Western Desert, it's a closed system. You have to bring the water from sometimes what's really popular in Western Desert is Mohra. This Mohra almost like 600 meter depth. You can bring the water, and the water is really salty. You can you can bring water to the surface with 200,000 ppm. This is the really salty water that we bring it from deep Mohra. This Mohra reservoir, it has two parts. It's either shallow Mohra or deep Mohra. And shallow Mohra is like it has fresh water that we use it sometimes for agriculture, but deep Mohra is really salty water. That you have to choose between shallow Mohra or deep Mohra, and sometimes we are using very deep reservoir, like in Cretaceous, for example, we have Kharita, or in Gulf of Suez, you have Nubia. Okay. Then you take this water through the facility. It might be a really big facility, like I said about GAPCO. They have in GAPCO, for example, they bring the water, take it through strainers. This strainer takes the water from the strainer directly to the gravity segregation big tanks. Then you take the water to the tower where they deoxygenate the water through big towers. Then they take the water through filters, and this is really the multi-stage filters where they take the water quality to microns, so you can find it's the water turbidity. Usually we measure the quality of the water with turbidity and TSS, which is total suspended solid. And in GAPCO, through this plant, we can take the TSS down to 0.2 ppm. Okay, and turbidity also for 0.2. And if you are in the Western Desert, takes the water from aquifer. Usually the water coming clean, and with it should be without oxygen. That's why you have closed system, and you might take the water with 2 ppm. It can be almost like the total suspended solid. It can be 2 ppm, and turbidity can be in the range of 2 as well. Yeah, so then you take this water through a closed pipe and re-inject it once again in your injector. Yeah, and it's a simple completion. Then the water is produced once again through the producer. The other challenge, and it's really challenge right now in Egypt for every company in Egypt, is how to get rid of the water. Yeah, it's you live really fancy type. When you start injecting water, then the water oil production start to increase. I have seen some fields after you start the water injection, the oil production increased from a few hundred barrels up to thousands of barrels. So one of the fields which I worked on started with 200, 300 barrels of oil coming from your producers. Then it went after in a few months to 4,000 or 5,000 barrels of oil. And this is really lovely. You can see the impact of the water flooding in a few months. However, after the water start to break through, you need to get rid of this water. That's why you need to plan ahead in your project how you dispose the water. And like I said, in GAPCO, for example, because of Gulf of Suez, you have another big facility to process the water and dispose it in the Gulf of Suez again. But in the Western Desert, in the past, they used to use soakaways, which is they dig big hole on the earth and the ground, and they decimate the water or dispose the water in the desert. This is against the environmental. That's why the Egyptian government decided this is not allowed anymore, and people has to get rid in a proper way in the Western Desert. That's why you have different techniques in the Western Desert right now. Either you drill disposal wells or to dispose it in the depleted aquifers or bugs reservoir, fracture reservoir, or you build really big evaporation ponds. I'm not taking you through all that things, but I'm just trying to let you know how complicated is the water flooding project. So it starts from.
Engineer Zahran, can you speak slowly?
Okay, I'm sorry. So if I re-describe this, quickly summarize this again a little bit slower. The water sourcing is one of the key elements. I describe it slowly. And disposal of the water is really another big issue. The water disposal project can cost you millions of dollars. So if you want to build a proper water injection water disposal project, it can cost you millions of dollars. Okay? This was almost like introduction. Like I said, water flooding need integration from different aspects, different disciplines. I'm not taking you through this, but I'm just telling you that you need a geologist, you need a reservoir engineer, you need a geophysicist, you need a geologist, you need a reservoir modeler, you need facility engineer, you need people from commercial background. Sometimes you need organization capabilities. Sometimes you need to double the manpower whenever you move from depletion to water flooding. Okay. What's important to design water injection project? You need reservoir geometry, for example. You need to understand the reservoir geometry. You need to understand the lithology. This slide can come with a presentation of 1 hour. That's why I will tell you a quick flavor about this slide. Like I said, I will anyway in the presentation I will show you some example for the reservoir geometry, so this is not a problem right now. In the lithology, for example, which what's one of the key aspects of the water flooding, you need to understand the lithology and the composition of the reservoir. And the composition of the reservoir is not only sand, sometimes carbonate, and sometimes clay. Clay is one of the key aspect or key element or minerals in the water flooding. You need to understand it very well, because there are so many different types of clay. For example, if you have light or kaolinite, this is a type of clay that it causes fine migration. If any one of you heard about the fine migration, which is a type of clay when you produce at a certain rates, it start to move and block your reservoir and create formation damage. But if you have any of those type, light or kaolinite, you might have fine migration and end up with formation damage. So you start with water flooding, okay? And by the way, the water injection can stimulate this light and kaolinite to move, and you start with a project with the intention that you increase your production, but you lose your injectivity or productivity. And the well which is producing something like 2,000 barrel start to decrease over time, and you can come down from 2,000 barrel, for example, to 500, even sometimes stop producing. Although you have the pressure, you lose the productivity or injectivity. And by losing injectivity or productivity, you might lose the asset. You drill a well, for example, in the Gulf of Suez with 20 million, and because you lost your productivity or injectivity, you cannot use this well anymore. And this is 20 million, $20 million. In the Western Desert, you spend 5 million on average to drill a well. Then you lose injectivity because of you are not managing your reservoir in a proper manner. That's why. If you don't understand which minerals you have in your formation, then you destroy your asset. Some types of minerals like smectite, for example. Smectite can cause clay swelling, and this is another type that can block your reservoir, and you lose also your injectivity if you are using fresh water. So if you are using fresh water smectite, mainly some other clays also can do the same, but you lose your injectivity and you lose your productivity. Some other types of mineral like pyrite, it causes the acid water to produce H2S. H2S can kill everyone, can destroy your facility. That you can build a facility with $millions. When you build the facility, it can be even $100 million. Then if you produce H2S on a level that is not properly already considered in the design of the facility, you might lose your facility. You might kill people. But if you don't understand that you are producing, you are souring your reservoir, you might lose your facility and kill your people. Okay. Then afterward, I'm just putting some light about understanding of the lithology. Then the reservoir depth itself. Are you for example, are you working with deep water, for example, and have really high pressures and very hot reservoir, or are you using with shallow depths and cold reservoir? This is really important as well. Saturation, if you start with high saturation, water saturation or gas saturation, you're also starting from, it starts very late, and you might not have a good result. If you have viscous reservoir, water flooding might not work. This fluid properties. If you sometimes with viscous reservoir, you need to find another way to manage your injection. Most likely water flooding will not work. Relative permeability, sometimes you have oil wet reservoir. It needs some different understanding, different design. It can work very well, but if you don't understand this from the beginning, you might lose your asset as well. You might not have a good result. Then you need also to understand the primary drive mechanism. This is a really good point, because I have the pleasure to be in Suez Canal graduation project like I did with the Future. And what was really surprising me, some people using water flooding in a strong aquifer. So sometimes you find people is coming to add value to a strong aquifer by draining water injection wells, and really this is really horrible. I have seen this with different universities. People try to design the water flooding, although they have a really big gas cap or they have strong aquifer. If you have a strong aquifer, you don't need for sure water flooding, because usually you get the strength from the aquifer. Sometimes if you have gas cap, you need to be very careful before you start the water injection. That's why you need to understand very well the primary drive mechanism. I had the pleasure to be with the Future, and they did really good apart from the project in the material balance and pressures and production performance. They need, before they implement or plan water injection, they need to understand the drive mechanism. Not every drive mechanism you can implement water flooding afterward. Depletion can work very well. Gravity can work very well, but if you have gas cap, it can work. But before it works, you have to give so many consideration, have better understanding before you start implementing water flooding, because you might have really severe problems. Pushing your oil back in the gas cap, you might distribute your ORM everywhere, so it end up with lower recovery factor than you planned ahead. In the strong aquifer, it might be a big problem. So proper understanding of the drive mechanism is one of the key drive design aspect in water flood. Okay, this is a really simple slide. I think you can read it. I know every student know about it. Without water flooding, you can get out from your reservoir from fluid expansion just only up to 10%. It can go sometimes with gas in solution up to 18%, but that's the maximum you can get out of it. You cannot get from depletion more than 18 or 20%. This is extremely high value if you get 20. But with you have for different drive mechanism, you have different recovery factor. For anyone of the students that doesn't know about the recovery factor, if you have a reservoir that has some oil, it can have 5 million, 6 million. You cannot forever, for sure, produce every barrel of oil from your reservoir. You have only the chance to produce some of it. Some of it depends on the energy in the reservoir that it can produce, and some of it depends on the fluid properties itself. So based on and the rock properties itself. So it depends on rock properties, depends on fluid properties, depends on the energy. You might have different recovery. So, for example, and you can imagine this with me. If you have 5 million barrel somewhere, which means considering $50 per barrel, so that for example, this is like $2 billion, for example. So 5 million, and you multiply, like $250 million in the bank. So if you have 5 million in the reservoir, this is like $250 million in the bank. So now you are as a reservoir engineer or a team lead, your objective is to get from this money as much as you can. Isam, you're raising your hand. I have someone is called Isam raising hand. Do you have any question or?
Sami, we can open the mic for you if you want to ask any question.
Okay, until Assam can talk, I will continue. So like I said,
في سؤال تاني محمد عبد العال. Is there is a clay reservoir?
no, there is no clay reservoir, but there is a clay mineral like sand cannot be consolidated without another mineral. We call it cementing material, and usually the cementing material is a clay. One of them is a clay. Sometimes it has carbonate. Sometimes your reservoir, sand reservoir, is close to another shale reservoir. So there is no there is nothing called a clay reservoir, but you have clay's content into your reservoir.
Okay, في سؤال تاني. Recovery factor is estimated by recoverable oil divided by original oil in place.
Exactly.
Okay, تمام.
So it's we have usually recovery factor is how much you can produce or produce. This is the ultimate recovery factor. For example, the recovery factor is how much you're producing divided by the original oil in place. And like I'm giving you as an example, this is a really simple example that you have 5 million barrels in a reservoir. And this reservoir, for example, like I said, the cost per barrel is $50 per barrel. And the total value of this reservoir, if you produce everything, it will be like 250 million. And I want you to imagine that you have somewhere you have 250 million, and you have to get out of this place as much as you can. This is your responsibility as a reservoir engineer, or even asset lead, or another discipline that contribute to the project. Okay, but if you are happy, I'll just finish this and I will get the question. Okay, but you can imagine with me that you can produce from this 250 million just only 10% because there is no energy. You have just only depletion, or it can be 15%, which means that you are leaving so huge amount of money in the reservoir. Don't look to the barrel of oil as if it's barrel of oil. It's look at this in dollar, measure it into dollars. So now you instead of getting the 250 million, you just only getting by depletion like 25 million, and you're leaving behind a huge amount of money. Then if you are the owner of this asset, you will definitely think about another technology that brings this more money from the reservoir. By implementing water flooding, you can go in some cases up to 60. For example, you can use get up to 60% recovery factor, which means you will never get 100%. But getting 60% means that out of this money, you're getting, for example, 150 million, which means that you're adding to the company something like 100 million, for example. Can you imagine that you are as a reservoir engineer, or as a petroleum engineer, or a geologist, or asset lead, you can add for a company by thinking deeply about how a proper design a water flood project. I can add 100 million from such a small reservoirs, 5 million. I worked with GAPCO on a reservoir that has 700 million barrel of oil. I have seen in the Gulf countries they have billion in a certain reservoir. Can you imagine those billion? If you have each 1% in recovery factor, how much it will be? Each 1% of recovery factor in a reservoir that has a billion oil in place, it will be something like 100 million barrel. Sorry, it will be something like 10 million barrel, something like $5 billion. So it's huge amount if we add just only 1% recovery factor. So that's why I'm just stopping at that slide. I can get back to the question if you want.
Okay, what is the maximum recovery factor achieved by water flooding in reservoir like sandstone?
Sandstone usually can go up to 60, like I said, or 65. This is maximum because you cannot produce residual oil saturation, for example. You cannot, there is area and vertical heterogeneity, so that you cannot produce every barrel into the reservoir. You cannot chase every barrel for sure.
Overall recovery factor.
Do you have any other question? دكتور
حضرتك 60% overall recovery factor is around.
overall طبعا not only from water flooding. So
مظبوط يا
you're
فندم.
adding another something like 40%.
مظبوط يا فندم.
I have seen in GAPCO, because GAPCO is very old project, some reservoir went up to more than 50.
Morgan.
Like for example, you have North Central, they have for example Ramadan, for example.
Okay.
You will find
Yeah,
some areas that went up 50. It's not every the whole field, but some blocks out of it. Okay.
Correct. Yeah.
In July, for example.
Correct.
This is total recovery factors, not only water flooding. So this is depletion and water flooding. Okay. So, like I told you since a while, if you start to اتفضلي.
What is the difference between the 5 mechanisms?
Say it again, sorry, I couldn't hear you.
What is the difference between the 5 mechanisms?
The 5 mechanisms. Okay, this is.
He means the 5 driving mechanisms. Depletion drive, water drive. No.
Okay, I thought you studied this in this, but it's okay. Fluid expansion. Fluid expansion. This is just only like anything in the world. If you decrease the pressure, everything expands. So water expand, oil expand, rock expand. So this is above start producing gas. Our oil usually has gas content. So any oil barrel usually has gas content. That's why you have RS gas in solution. The first part, which is under depletion, without any energy, just only by you produce a barrel, that the pressure decrease, then another barrel move. Okay, due to the same particle expand in size. This is just only expansion without any gas liberation. Then after you reach the bubble point, some gas start to liberate, and the gas is really fast, and any bubble of gas can move fast. That's why it will bring with it more oil. So what we call usually depletion is fluid expansion followed with solution gas drive. Fluid expansion, that's because whenever you produce from the rock, which is compressed due to high pressure, another barrel is coming to your well. That's why due to expansion, rock expand, water expand. Then you reach the bubble point, then gas get out of solution, and when this gas get out of solution, it's carry with it oil with it to your wells. But the first is the fluid expansion and solution gas drive. Those we call it usually depletion drive. And gravity drainage when you have tilted reservoir, which means inclined reservoir. And the inclined reservoir, very inclined reservoir, when you have gases, the gas doesn't go to the wells. The gas go to the up dip of the reservoir itself, okay, and push the oil down. So you have at that we call it for it creating a secondary gas cap, for example, or you already have a small gas cap, and any gas that are produced from your reservoir doesn't go to the wells, so that you are not depleting your energy. You just go on the top of the reservoir and push your oil down to your wells. This is what we call it gravity drainage. Exactly what you like. If you have a cup of water and oil, you have the oil on the top of the water, and the oil is pushing the water down. And if you have gas, it will push both of them down. Okay. Gas cap, when you have a reservoir that has a huge gas cap. And in this time, if you have really huge gas cap, we call it the oil is oil rim. You have like a piece of cake in the middle of huge gas, and it's really difficult and very challenging because if you start injecting water in this huge gas cap, you push the oil in the gas. And the gas, for example, if you gas cap, you can imagine like I have a balloon, and this balloon has only gas in it. But if you drop some water, it doesn't change any pressure in the reservoir. The pressure is decided and identified by the gas of the pressure, of the gas pressure. So the gas is the energy that drives the oil production. Water drive, for sure, you know, everyone know it. Say you have a huge water lake or connected to your reservoir, which is a huge aquifer that bring energy to your reservoir. So this is the water type. Okay. If I move on quickly again, this is how it looks like the production if you start water injection. Usually, this one of the this is real data for sure. This reservoir was it was producing at a certain level, 1.5 million, for example. Then with time it's increased due to implementation of water flooding. Then the water production you start producing more water. Then you have your production going down again. Then you can see that you have very long tail. This is, if anyone of you had studied relative permeability, I will take the chance to teach you more about the scale in another session. You will see that the curve of relative permeability is turning down, like or flatten at the end. And this flattening means that you still can produce the same water cut for long periods. It might be at a certain saturation, you still has a lot of oil in the reservoir, and due to the flatten of the relative perm at the end of saturation, before reaching the residual oil saturation, you might have the same water cut for long period. And that's what I refer to as oil wet reservoir. In the oil wet reservoir, this flat is really big. Yeah, it's very it's covered very long saturation. So on the oil wet reservoir, you can even get higher recovery factors than water drive if you manage to produce for very long period, which is not practical for sure. That's why some people assume that oil wet reservoir cannot produce high recovery factor. It can produce high recovery factor, but you need to inject a huge amount of water, handle a huge amount of production, and this usually is not practical. That's why people satisfy with less recovery factor. Okay. Then for sure, like I said, you have decline rate, and the decline rate can be 55 up to 20%. Sometimes it go, you lose 30% of your production on an annual base. Then if you have water injection, you start reversing the inclination. So you start having increase in oil production. It can go up to 30%, which means that in each year you can, for example, if you have 1,000 barrel at the end of the water flooding, you will have, you start, instead of losing production 30%, and let's assume that under depletion. If I start the year with 1,000, and I will end the year with 700. But if I'm implementing water flooding, I will end the year with 1,300. So you gain something like 600 barrel. Okay. Usually, if you implement water flooding, usually in water wet, you inject something like 2 bore volume, which means you have the size of the reservoir, the bore volume, which you have it, and you inject from 2 to the 3 until you reach the high recovery factor. In the oil wet, you can inject up to 10 times the size of the reservoir. So the project will have longer time, and for sure a huge amount of water injected and less economics. Okay. This is another graph showing you what the depletion would do. This is I have been in the university attending the project a few months ago, and they use decline curve analysis. This shows the depletion, and if you're implementing water flooding, okay, your production starts going up. Then after water breakthrough, it starts going down again. I will put some light about. تفضل دكتور.
باشمهندس زهران, I'm very sorry. Really, I need to have something to do now. So really, I wish you all my best with your participant in this lecture. I am going to miss it for the time being, but of course, I will refer back to you, inshallah ta'ala, later. So excuse me for leaving the meeting now.
اتفضل يا دكتور. انا يعني سعيد بحضور حضرتك معايا، وشرف لي كبير قوي يا دكتور.
الله يكرمك. شكرا جزيلا. Thank you very much, باشمهندس. Keep on. يلا keep on معانا. شكرا.
this graph depicts the water, how the water is moving from injector to producer. Like I show you, this is like oil only. It has 50% oil, have 25% gas, and have 25% water. And if you start water is not moving like a piston like that everyone think. Water start to move and bypass some oil here and try to compress the gas. And you can see here the gas much less because you are getting the pressure above the boil point. That's why again the gas is going away until the water is breaking through, and you still have behind you have oil and the gas. Okay, I have a question, I think.
Yes, we have many questions. Why it isn't possible to reach more than 60% of recovery?
Because actually you have residual oil saturation. It's something like a wettability. It's usually on the wet reservoir in the range of 20, for example. This is 20%. You cannot produce it with water only. And I will tell you something quickly to make it easier for you. I'm not sure how many foreigners do you have on the call. Do you have anyone? Because I can explain a little bit in Arabic if you want.
Oh, okay, مش مشكلة.
يعني do you have if I have foreigner here on the call, can you please raise the hand?
What?
Okay, we have a few foreigner. No, it's a lot.
في أسئلة كتير جدا.
I will bring it easily for you. I know that ladies, but man right now we can washing clothes. Okay. Like أنا بتكلم دلوقتي على الغسيل ماشي عشان لو حد missing me. So can washing clothes. Your mother, for example, when your clothes is dirty, drop some oil on it or something like that, eat and spill on yourself. Doesn't matter. Your mother decided to clean the clothes for you, and if she clean only the clothes with water, it will never be cleaned. You will still see some spot of oil on it. Okay. But your mother is really smart using the technology. That's why she will decide to do using some surfactant. And this surfactant, like Ariel or Persil, whatever you call it, this is surfactant. This surfactant will make your clothes more clean. But still, if you have more oil and sticky oil, it might end up still not clean. That's why your mother also use the washing machine. That's why this is what we call it agitation. Okay, and sometimes using hot water. So by using the three techniques, surfactant, agitation, you have which is mixing, good mixing, and having warm water or hot water or steam, for example, you might end up cleaning your clothes. But if you're not using this, those technology together, okay, you will not clean your clothes. The same is the rock is texture, like your clothes. You cannot clean it 100% with only water. You need surfactant. Sometimes you need steam. Sometimes agitation. You need mixing long time. So you need every piece of it to be touched with water. So this is not possible actually. So you have to leave oil behind because the wettability, for example, because you cannot drill well everywhere. That's why you must leave oil behind. Okay. What we call it later, vertical sweep efficiency, aerial sweep efficiency, displacement sweep efficiency. This is what we call as technology. But if you get back to your anyone get back to his mother, or he tried to do this lovely experiment with by himself, it will work like this. Water never clean your clothes from oily sticks. Okay.
Okay. There is another question. In the case of water flood, how about microscopic and volumetric displacement efficiencies?
So I prefer this is I will answer this question later. So I will move on now, and I will give you another let's answer only the questions related with the slide, but if something out of the slide, I will answer all the question at the end, okay?
Okay.
Yeah, so if you help me, just only give me the questions related to the slide. Other than that, I have the pleasure to spend with you as long as you want answering your questions, okay?
Okay.
Okay, so quickly also, I will tell you something here about this. When I start water injection, at which pressure? And this is really dodgy because in theory, everyone will tell you bubble point. Okay, this is the theory, and usually this in theory is the most proper time to start the water flood. However, in practical life, this is not usually what we start. Usually, you need the water flooding for two reasons: building pressure, sweeping oil. Building pressure, sweeping oil, and building the pressure will help wells to produce. So sometimes you start at the initial condition, so you help wells to produce more. Okay, so you at this time you're producing from your wells as much as you can because of the productivity index and pressure. Especially in the tight reservoir. If you have tight reservoir, usually you cannot start. I don't advise anyone to start at bubble point because tight reservoir, it will not produce anyway. It's producing very little oil. So you need to understand, compare the value of producing oil today or getting some more oil in the future. Okay, some in Western Desert we have worked with fluids that is like dead oil. It doesn't change too much the fluid properties between initial condition and bubble point. That's why you still starting with initial condition, but you achieve really a high production and you are not missing a lot of reserve. But the optimum condition in theory is bubble point. But I'm advising people to think about what bubble point. Is that the bubble point of average reservoir pressure? Because you don't you have especially in tight reservoir or heterogeneous reservoir, you have different reservoir pressure. Or the BWF, which is bottom hole flowing pressure. I usually advise my friend to design their initial pressure on the bottom hole flowing pressure. So try to keep your bottom hole flowing pressure above bubble point with a couple of hundred psi, because usually water flooding will not continue all the time, running all the time. It will stop for a while. Then you will drop blue bubble point. Okay. If you drop blue bubble point, you lose in the productivity index and lose energy as well. Okay. Some people, you can stop me anytime if you see that the question is related to my slide. Okay.
Okay. There is a question. What is the bubble point pressure?
Oh, this is really difficult question. Bubble point pressure is the pressure at which the first bubble of gas getting out. If you have soda or drink Coca-Cola, for example, you have the Coca-Cola, when you open it, you have a lot of bubbles coming out. Those bubbles is usually the first bubble which appear in your oil called bubble point. Okay, where the gas start to elaborate out of the oil. Okay, any question? Other question? So usually you prefer that your gas, all the gas in the oil, because if the gas get out of the oil will be like dead and like when you bleeding. Getting gas out of oil, like you as a human get bleeding, okay? Losing your energy. Okay. Go ahead. If you have another question.
No question related to the slide.
Okay. So I will move quickly. This slide, the remaining slides, not too much. It has a lot of pictures more than talks. That's why it will be much easier. If you going to design water flooding, this is practical. You might understand this is how it looks like your reservoir, the channel, how it looks like, because you need to drill wells. And drilling wells, you need to understand where you drill wells. That's why you need to bring your core data, this core data, understand porosity, permeability, everything about it, relative permeability. You have to see which layers you have, what's the inclination, and you need to understand from seismic where is the faults, which is the horizon. Then integrating all those data together bring to you like a geometry of your reservoir. This geometry is something. Where is this channel? And for those asking, I think there are a few people are not petroleum engineers. When I'm saying reservoir, you must know one thing. Okay, if you know river, this river has water, but our reservoir built on millions of years. That's why if you take this water out of the river and put sand instead of water, this is our reservoir which we drill in. So usually reservoir geometry like river, like lakes, and etc. Okay, you need to understand. Sometimes it does take so many directions. It going to east and from east to west. Sometimes it cut in different channels. So you need to understand. So you need to drill wells later. This is really practical. If you miss anything from those, you might miss proper development of your reservoir. Then usually you build a 3D model, like I'm showing you in this graph. This 3D model showing you which layer and what type of property you have for each layer. Then on the edge here, you can know this is channel, for example, this is channel, and this channel, you know where you can drill wells. I can drill well here, I can drill, but firstly, geologically, you must understand the geometry of your reservoir, and those different tools coming together to tell you what's the geometry of the reservoir and what property of the reservoir. Okay. If you miss anything of that, you're heading for failure. Okay. This is some example showing you if a small core, this core we're getting from the reservoir is something like 2 inch. It's like your finger, as small as your finger. From a reservoir with dimension of kilometers width and kilometer length. And by understanding this, you might understand the porosity, permeability, what is the fracture system, and etc. Okay. This is a texture of the reservoir, and it's lovely. This is a question which I have been asked before. Does my reservoir has clay? Yes, this is a texture. This is under microscopic. It has sandstone in the middle. You can find some clays in between that hold the sand together. Okay. It can be carbonate, it can be sandstone, but at the end you need you might have clays. And these clays will decide what type of saturation you can see, what's permeability, and porosity relationship you can have. You might have different reservoir with different relationship, and etc. Okay. At the end, you have this lovely texture. It shows you this reservoir. It's not continuous. It might have some shale in between. That's why this shale, if you drill well here, it will not. You will see sand and shale, and etc. Okay. This is a photo showing you sometimes your reservoirs, if you are working with carbonate like Gulf, like Aramco, for example, you have fracture system. This is like a fracture. If you inject water here, it will not go in the matrix. It go only the fracture. Okay. This is what we call outcrops. I advise every one of you to get out for field trips and see outcrops, because our reservoir is exactly like this, but they are 3 kilometers into the ground. But our reservoir is the same like this. It has layer like this, it has channel like this, it can be continuous like this, can stop like this. But exactly what you see, we call it outcrops on the ground. I have the chance, I was really happy to see outcrops in Sinai. It has really lovely, it show everything in Gulf of Suez. Each structure you have in the Gulf of Suez on a 3 kilometers depth, you can see it on the ground. You can imagine what type of what the reservoir was, what fault looks like, what conformity looks like, everything. It's lovely. Yeah, if the student can arrange one trip to for example to Wadi Hitan, or you have close to New Cairo, you have different outcrops. So Muqattam itself, where I'm broadcasting for you, it has its own outcrops. So you can go and get out, have entertainment, and also see outcrops. Okay. This is one of real cases I'm showing you. We didn't know where is the sand going on. Sometimes we say sand going like this, some sand like this. So by integrating with the data together, you might know this, where is the sand going on to drill wells. Because if you think that the reservoir is going like this and drill wells here, you will not find anything. If you might to drill injector and briefly you might know where is the sand. Okay, I'm just going to the end quickly, so that I then just bear with me. I know that there is a lot of questions, but bear with me for a while. This is a real data from water flooding, and you can see here after running the simulation, building those cases, you can run simulation forecasting the water flood. Do I need 5 wells, 5 injectors? Do I need 6 injectors? Do I using 5 spot pattern? I need 9 spot pattern. Everything you get it from simulation. I prefer using simulation for initiating water flooding. I prefer using simulation. That's why usually people start with an analytical tool, but I prefer that you understand simulation deeply. That's why the next session will be about simulation. I will not spend more time here because I will give you another session about simulation and what consideration you need to take while designing the water flooding. Okay. Then jumping quickly from underground and subsurface, I just would like to show you a couple of pictures for bad management of the water flooding. Okay, because water flooding with water, suspended solid, corrosion can come. Oil doesn't come with corrosion. If you have at home your taps, where you'll find corrosion, you'll find scale. Oil is lovely. It can go within your reservoir without problem, but water, when touch anything, it comes with problem. It can come with H2S, come with corrosion. Your tap at home bring a lot of corrosion, a lot of rust. So I will show you it can come with HSE issues. But this is a real cases. You can see a water injection. This is bacteria. You can inject this water. This is coming from the produced water. If you inject this water, you will lose your well. You spend 5 million, you spend 25 million. If you spend this water with bacteria, you destroy your well. Okay. The end result, this is rust coming with injecting water with oxygen. This a real case. This is This is corrosion because of your water. This is the infrastructure which you have. Then you have a lot of big issues. Okay, that's why people usually use chemical injection. This is another case. This is a leak from water injection well. If you inject this water, this dirty water, it will come with H2S. It will come with corrosion. It will plug your reservoir. You will lose the ductility of the reservoir. Okay, this is steel. This issues with steel. Some people try to save money. That's why use those type of chemical skids. Chemical skids really expensive. They bring chemical to inject chemical. Some people in the past were really smart to save money and inject from those barrels. This is real case. But at the end, this is how it looks like. It must looks like you must inject chemical, ensure the chemical is continuous, that you are killing bacteria, using biocide, using different type of biocide. You need to understand which bacteria you have. You need to deoxygenate your system. Everything, it has an impact. You need to inject skill inhibition. I can spend days and days talking about water flooding, but we don't have days and days. Okay, that's why this is how it should looks like. At this level, I'm ended. I can end my presentation and take your question. Okay.
Okay.
But let's have 10 minutes. If we have question after 10 minutes, then we have a break. Then continue again. I leave it for the organizers. Okay. Any question?
Though after hydraulic fracturing doesn't produce more than 60%.
So let me first answer the question of the guy who asked about displacement efficiency and those type of things. Okay. Usually, recovery factor is a multiplier between 3 factors: recovery, displacement efficiency, vertical sweep efficiency, and aerial sweep efficiency. What aerial sweep efficiency? How much you produce from aerial? Okay. Yeah, you cannot produce everything aerially because you need to produce aerially, which is we are talking about area now. I'm talking about مساحة. لو الناس عارفة المساحة. This area to produce every barrel net, you have to drill well everywhere. Okay. Vertically, you have different property of the sand. Some have tight, some have permeable. That's why water doesn't go everywhere at the earth. That's why you have different technology to measure this aerial sweep efficiency. You will find graphs and Dides already have his methodology for 5 spots. You can use Dides. This is a name of man. You can use it to calculate the area superficiency. Vertical superficiency has too many technologies. That's Traberson, you have Lorentz, you have Stiles. Different ways you can measure the vertical superficiency, considering the vertical change in permeability. I can spend also 1 day teaching how to calculate the area superficiency and vertical superficiency. Then you have back leverage for displacement efficiency, how much I can produce from my bores. You have Welch, you have many other methodologies. If you multiply the displacement efficiency by vertical superficiency by area superficiency, you end up by recovery factor. This is what we call analytical methods. And it's lovely. We can teach it for the people to learn how to use it and understand more about water flood. But practically, those technologies 50 years ago and simulation can be used in a more better way. Okay. Getting back to the fracture.
Okay.
What was the question again?
Though after hydraulic fracturing doesn't produce more than 60%.
Hydraulic fracturing only stimulating the production from the well. Well can produce 30%, 300 barrels. If you hydraulic fracture the well, it's produce 100. So 1,000. Which means that you accelerate your project. Okay, and usually it helps only that it helps only in the depletion, because in depletion it minimizes for you the bottom hole from flowing pressure where the well ceases to flow. But in the water flooding, it will not just only frac does increase the recovery factor usually, except in some special cases. But hydraulic frac accelerates the project, which means that instead of running the project in 20 years, you can finish produce your recovery factor in 5 years or 10 years. Some hydraulic frac can help if it's properly designed. If it's not properly designed, can hurt the recovery factor.
Okay. There is another question. I was wondering, what is the effect of bacteria on our well?
It has so many effects. Bacteria, for example, if it's measured in colonies, and there is so many types of bacteria. You have aerobic bacteria and anaerobic bacteria. Bacteria can, for example, create local corrosion if they are doing like shield, and you might start have leak on the surface facility. That's why if you start leaking the surface facility, then you have so many problems. The facility doesn't contain the water. That's why you need to stop the project, and you have so many issues. You have corrosion issues, bedding, a lot of things. But the major issues, bacteria usually is creating gases, and the most dangerous and risky gas which bacteria can produce is H2S. Everyone studied H2S in the I think in the secondary school. H2S doesn't have you cannot smell it if at a certain content, but at a certain another when it's at lower content, lower ppm, it's like corrupted eggs. You know that if you left an egg for a while, for a few days, or open egg, broken egg, it will have really bad smell. But at a certain level, you cannot smell anything, and it can cause fatality. It can cause people to die, and cause facility to break down. So usually water injection with bacteria can cause those type of gases, which can destroy a facility, kill people, and everything. H2S is really dangerous, really dangerous, and can come with a lot of cost to the project. Okay.
How do we determine the primary drive mechanism in the particular reservoir?
By production data, by material balance. If you have your production data, you have pressure, you can use material balance. You can understand your drive mechanism. I think you are in the future university did a great job in doing this in the project.
What is the difference between water flooding and water injection?
This is for me like a debate between scientific people. Don't worry about it. Some people saying demonstrating that sweeping and some about pressure, some considering water flooding as secondary tertiary recovery and water injection as primary recovery. It's different ways of designing a project. You don't need to go deep about it. Usually people use it to confuse people.
Is the oil that we get out from condensate reservoir is considered in the recovery factor or not?
This is a lovely question. The answer, usually you have condensate drop out from gas. And for sure, if you shouldn't consider this because if you consider it, you must consider the volume itself, because condensate was not part from the oil which you are oil in place. But, to calculate the right recovery factor, you must calculate the recovery factor, okay, from the oil which you are producing. Otherwise, you have a higher recovery factor because either you bring oil from a different source. But so I don't. It's not the proper way to bring to calculate condensate as part from the recovery factor. However, most of the people in practical doesn't distinguish between oil coming from oil rim and oil coming from the gas zone, because it will be really challenging to differentiate. So in practical life, you usually use the summation of both of them to calculate the recovery factor. That's why recovery factor sometimes will be higher than it should be. However, in theory, you must just only calculate recovery factor from oil produced from the oil rim, not from the gas cap.
Is water flooding is the best method to use after polymer injection, and what needs to be taken into consideration when switching from polymer injection to water flood?
No, polymer usually used after water flooding. It's not before. Sometimes you start with polymer injection. If you, for example, if you have high viscosity, you need polymer, but you need to be very careful. This technology will impact you need to have proper design. For the polymer, its impact on the production facility, and because you might have also polymer will give you higher recovery factors than water flooding, because anyway you're using polymer with water. You're not inject polymer without water, or even surfactant. So polymer or surfactant will be injected with water, but it needs careful design and more consideration before implementing. But it comes actually with higher cost, and you need to understand the impact on the surface facility. Production facility. Next.
Okay. Whatever the percentage that has been recovered from water flooding, is that counted as proven or possible reserve?
This is actually this is a really nice question, but it's a really difficult question to answer in a very short time. It depends. For example, you have in the reserve, you have proved reserve and what we call it B1, and probable reserve and possible reserve. You can, after the success of the pilot, can consider it as probable or possible reserve, but to be proved, it need to consider, you have criteria that you need to consider before you consider or write your reserve water injection as a reserve proved. But yes, the answer after the pilot success, you can write it as probable reserve, but proved reserve needs a lot of consideration. So I might have a lecture for that later, but because this is really lovely question. Most of the people do it right, wrong. What part from the water flooding need to be considered as 2C, which is like a resource, contingent resource 2C. What part from it should be 1B, what part will be 2B, and what part will be 3B. This is really a lovely question, but it needs so long time. Okay. If this, if you need me to have one-to-one discussion about this, I'll be glad to have one-to-one discussion. But this is like a lecture. Okay. Another question.
Whatever percentage that has been recovered from water flooding. Oh, okay. Sorry. What is the difference between water cut and water coning?
No, this water cooling usually if you have oil on the top of on top of water, and you produce with very high rate, then water do like a cone. The water level, for example, will be at a certain level, but because of the coning, the water will go for a higher level than the water oil contact. You have, for example, if you have the water oil contact at 10,000 depths, and you start to produce very high oil, high production rate, then the water will come, for example, 5 meters shallower around the well only, but not everywhere. That's why you are bypassing a lot of oil in the reservoir. This is what we call coning, like cone. اوكي زي القمع كده هتلاقي the water around the well like cool, and everywhere is still oil, so that's why you bypass a lot of oil. That's why we try to avoid cooning as much as we can. Sometimes if you have cooning, you might lose your well. Water cut is water cut. Every water is coming to the surface called water cut, but you compare water cooning with water cusping, water break, or water fingering, for example. Okay. This is what we call. If the watering coming up smoothly vertically, you can say this water breaks through, normal water breaks through, which is water cusping or something like that. And you can use chan plot. It's really old but nice method that can use it for to understand in practical if it's water cooning or water cusping or water bottom up water encroachment. Okay, and you have different surveillance as well. You can use TDT or RST in shut-in and flowing mode. It will help you to understand which one of them is going on. Okay.
Does water alternating gas have significant benefit compared to conventional water flooding?
Yes, in some cases. WAG usually is beneficial if you are implemented it in the right. You need to understand the geometry. Where is the water? You have gas, or you don't have how the structure looks like. It has a lot of domes or not. Then water alternating gas will help a lot improving the recovery. But if you are using it in the right application, choose the right application.
Okay.
We call it WAG. Very it's very approved technology as well.
Can we call the chemical enhanced oil recovery as improved water flooding method?
Again, you will not use chemical without water. You need water anyway.
Okay.
So if you add surfactant or use polymer or whatever, if you even steam injection, steam is coming from water, so they are coming together. But sometimes you are easily start from the beginning. We have here a scimitar, for example, uses half and buff steam injection in Egypt. It's very heavy oil. You cannot start from the beginning with water injection without. So they steam. They use steam injection. Some other companies use like Petrobel. They are using polymer. Or some I think Agiba used surfactant. So different now with people spend a lot of time thinking about the low sal. They consider if you are getting out of salt from water will improve the recovery factor. So there are so many technologies that can be used from the beginning or used after the water after injecting water for a while. It depends about the design from the beginning. Some like heavy oil, you cannot start from the beginning with water injection without using polymer or increasing the temperature until you steam the water.
Okay.
Okay.
What is the high temperature that SRB bacteria live in?
Bacteria can live up to 120. This is usually temperature Celsius. After 120, it will be difficult for bacteria to survive. Sometimes, let's say, who asked this question is smart enough to ask the question. That's why I'll give you another flavor. H2S has in theory, has two different mechanisms to formulate. One of them is biofilming, and the other one is mixing zone. Mixing zone, which is 120, usually it will not happen. But sometimes using the mechanism of biofilming, which is mean the H2S generated close nearby to the injector. Usually the injector injects cooler water, so usually you cool the reservoir, and the H2S is created, and whenever the H2S is created, it doesn't get impacted with temperature. So as short answer is 120 above, the more it's bacteria cannot survive. For example, also with this is Silesius. No one mix it with Fahrenheit. Also, if you are using a high salinity, bacteria also will not survive. So there is a condition that bacteria can survive. But for sometimes you can have H2S with high temperature because of the H2S get created around the injector itself.
Okay.
Next.
What is the difference between microscopic sweep and macroscopic sweep?
Macroscopic, like I said, aerial and vertical, which we call it usually a volumetric sweep efficiency. And microscopic inside the pores, like wettability, due to impact of wettability. Exactly what, the texture usually keeps some oil inside, like your clothes. When you have oil in your clothes, this is in the texture, okay? Inside the texture which is due to wettability, forces between rock and oil. And this is what we call it microscopic because into the pores. Macroscopic, MA, usually is called volumetric because you cannot drill well everywhere.
Okay. What is the difference between clay and shale in reservoir rocks?
Usually, each shale is a clay. Because clay is the size. Usually we call it size. Each is more very clay ده بنسميه بالعربي الواحد. خلاص. This is minerals itself. Clay, it has a mineral, and the mineral, like I say, is pnictite, like illite, like kaolinite. This mineral has plates, and between have some anion keeping them together. And usually they don't have porosity or effective porosity. They just only have total porosity. Very high, it has a lot of fluid in it, but it doesn't have permeability or it doesn't have effective porosity. A shale, usually it can be anything. A shale can be usually it's a clay, and usually when you say I produce from shale gas or shale oil, it can be sand, but very, very, very unconventional, very tight. Okay, so usually shale can be a clay. For sure, it will be a shale. Any clay will be shale, but the clay itself, a mineral. Plates with mineral in between can be pnictite, like light, kaolinite, siderite, pyrite, all those type. We call it clay. But the shale, usually, most likely it's clay, okay? But sometimes it can be sandstone, which is very tight, and we call it shale. And when we produce from out of it, we produce from shale gas, for example, shale oil. This is what I know. I'm not sure about that very well, but this is what I usually know about it.
Okay, and last two questions. What is the disadvantage of water flooding, and what is the role of bubble point in water injection?
Like I said, water flooding is a proof technology, but need to be properly designed. If used in the right application, you will not have so many problems. But we cannot say we have disadvantage for the water because we have problems, issues. Whenever introducing new fluid to your reservoir, you will have problem for sure, definitely. But we can have souring, like I said. You might have problem with the infrastructure, like corrosion. You have so many issues. You might not end with a commercial case. You might have higher recovery factor, but after spending so much money, and you might not be able to get rid of the water. But this will be a disadvantage. But usually, if you have proper design from the beginning, consider each element have economic design. You will end with favorable condition. What was the other question?
What is the role
bubble point? Bubble point. Bubble point is critical. I will tell about bubble point in another lecture for me about BVT. BVT is really not important element. I hope I can spend with you a few days, but BVT, I'm not usually call it BVT because I usually fluid characterization include part of it is BVT. That's why I will tell you more about bubble point later and its application, different technology. Okay. Any other question?
Hassan Muhammad is raising hand. We can unmute him and ask his question.
Go ahead. Sorry, I was really fast, but we spend a lot of time. If I'm not really fast, we will not be able to cover everything.
Hello, Mr. Muhammad.
اتفضل.
Actually, I have some question. I just want you to stay with me. The first one is when you present the table that presenting the recovery factor for the contribution for every drive mechanism. I was wondering from where these numbers are coming, because I see them always in the literature. But is it because of analogy or because of the studies, or I don't know if you get my question or not.
I got your question. So if you, usually this is best practice. I have a graph. Each company has its own benchmarking. For example, when I used to work with BB, for usually they have BB, they have their benchmarking. So what we call it analog. Okay, so you will find all this all over the world. They have it together. You can filter on the depleted reservoir, then will tell you the range. Okay, so still the same. Every company is the same, because usually the first step in the screening, you cannot do a simulation study. The first step usually is the analog. That's why big companies usually have a huge database, and I think the people in the literature bring this from the database. Okay, that's why with different literature you will find different numbers. Okay? Some number can have the basis. I can tell you, for example, depletion. For example, if you don't have, if you use full material balance and go to full material balance and deplete your reservoir at different fluid, at different beta O formation volume factor, definitely you will get different recovery factor.
Yeah. Actually, my second question is about the operating pressure for the injection. For the injection well. You said we have three cases. The first one when we are above the bubble point, and the one when we are equal to the bubble point and below the bubble point. So my question is, which method is better, and how can we ensure that we do not change the phase behavior of the reservoir fluid when we are injecting?
Okay. So anyway, if you're injecting above bubble point, you will not change the reservoir fluid. Okay, you are not even change the phase envelope at all.
But I'm talking in the cases when we are below.
Okay, but usually we are not managing below. This is the third case which I demonstrated. Some people in the literature, okay, and I consider it very theoretical, not even practical, and demonstrated in the presentation. Some people prefer to operate between the bubble point and the critical gas saturation, which means that you are not losing your energy, you still have your bubble there. The only advantage of this that the residual oil saturation is much less because you have three phase. Okay, this is really critical and practically cannot be managed. Okay, this is, you will find in theoretical the best is usually some people say that the best condition for sweeping efficiency is bubble point. Some other you will have this debate in the literature. Some other people say no, if you are depleting your reservoir slightly below the bubble point and you have some free gas but not capable to move, you have less residual oil saturation, that leave less oil behind. Okay, this is really dangerous. I cannot accept it in the practical life. What we accepted in practical life to operate above bubble point with couple of hundred psi, where you still, if the water flood stopped for any reason, you still keep your reservoir above the bubble point. But what's really important that you run a study before vertical lift performance and recovery factor. And because sometimes you need to go even much further. In Western Desert, we usually operate at a much higher pressure because you need to lift your wells. That's why sometimes we operate at 90%. Some cases we have been operating at 90% out of initial pressure. We are not usually operate at initial pressure. Sometimes also we over inject. That's why we might have problem with the gas with the cap rock. We might fracture reservoir or get out of the injection. So you need to have, this is not easy question. It's case by case. In literature, this is debate somewhere. I'm usually operating my fields. I'm not considering the reservoir pressures. In the literature, usually they are talking about reservoir pressure. In reality, I used to operate the BWF above the bubble point. Even that's why the reservoir pressure will be much higher than the bubble point for many reasons. Because usually, if you have water injection, is the best artificial lift will be ECB, and ECB will not survive with gases. If you have gases, you will have so many other problems. That's why you need to avoid gases in your pumps.
So you can make the most of all the technology that you have. So.
Yes, you might. That's why literature usually look to for piece by piece. Okay, but if you look for the whole system, you will not operate like literature all the time.
Yeah. Thank you. I just one question left is about the water weight and the gas weight, the oil weight to reservoir. So when I mean, does the water injection or can the water injection be used for the oil weight reservoir and give give a good recovery, or it's always we are always having problem with those kinds of reservoirs?
Usually, we can use for sure. You can use water flooding with oil weight reservoir. There is no problem with that. You must understand two things. Okay, we did in Shell so many experiments on the core, and a lot of them came that the residual oil saturation in oil weight reservoir is less than the residual oil saturation in water weight reservoir. This is unlike what we used to know about oil weight and water weight. And this is has a reason and explanation that in oil weight reservoir the remaining oil is not adhered to the rock. It's in the middle of the pores. Sorry, it's adhered to the rock, and it will be like a film, not like as you water weight. It will be like a bubble in the middle. Okay, but what's the problem then? The problem in oil weight that you need to inject a huge amount of water. That we need to produce also huge amount of water. That's why you must stop the project for economic reason, not for recovery reason. We are in oil and gas industry to produce dollars. Yes, oil is really important, but we are producing dollars. No one will spend money to when he starts losing money. Okay. So in oil weight, you stop if you run the project for 10 bore volume injection, for example, you might end up producing even higher than the water weight. Okay, but you will produce, for example, 95% water cut for years. If you are willing to do so, you will get the really high recovery factor. If not, you will for sure you will stop at lower recovery factor. I have seen that some projects end up 25%, 30% recovery factor, and this is still fine if you compare it with 15% depletion. It can go up even to 35%.
اوكي باشمهندس، ممكن ناخد بريك دلوقتي او نكمل؟ حضرتك تفضل.
انا افضل ان احنا end up هنا, and if we need another session, even if for a question, I'm ready also. Okay, you can say if the community want another session, because I have so many presentations. Everything I talked about can be a presentation, but I didn't know which one of them I choose. Do I talk about chemicals injection, or do I talk about reservoir management? Do I talk about simulation? Do I talk about analytical tools, how to use it? Do I talk about fluids? Do I talk about design? Actually, it was really difficult. That's why I have to select some. But if the community want to a certain lecture about something specific, we can have another session and answer question as well.
Okay, thank you, Engineer Mohammed Zahran. We can end the session now, and I will send the attendance form here in Zoom chat. Okay.
But I'd like to say something before you end. Thanks everyone for attendance. I know that it was so long lecture, something like 2 hours. myself, I just was planning only for 30 minutes, but I was glad that I had all those questions encourage me to do more session if you want. Thanks again.
Thank you, Engineer Muhammad Zahran. Thank you all.
Have a good day, everyone.
Please don't forget to fill the attendance form before you leave the meeting.